Great, this is our last video lecture on Chapter 2, and we are going to talk about objects that are undergoing free fall. Free fall means that an object is only under the influence of gravity, and it accelerates at negative 9.8 meters per second every second, regardless of its mass as it falls. However, in our everyday experience, we don't agree with this at all. We think that mass makes a difference. Take, for example, if you drop a flat sheet of paper and a ball from the same height at the same time, the flat sheet will just float down to the bottom and the ball will hit first. Why is that? It's not because the ball is heavier necessarily. It's because air resistance affects that sheet of paper differently. If I can reduce the air resistance on the paper so that it's not a big factor by balling it up, when I drop both of them at the same time from the same height, they both land at the same time. Now, I encourage you to try that on your own. So what happens when something falls and there is air present is that at first the only weight that's causing it to fall is its weight. That's the only force making it fall. And that causes it to accelerate at 9.8 meters per second every second as it falls. But as it gets faster, air drag or air resistance builds up on it. The faster it falls, the more upward air drag there is on it. And at some point, the air drag is exactly equal and opposite to the weight acting on it, and it no longer gets any faster. It's at its fastest terminal velocity. So in order for terminal velocity to occur, the air drag has to be equal to the weight. When we looked at our flat sheet of paper didn't weigh very much. Did not take it very long at all to reach the conditions of terminal velocity. So it reaches terminal velocity before the ball does. But by simply reducing the air resistance on it, it doesn't reach terminal velocity as quickly anymore, and it will tend to fall at the same rate as the ball. So we're going to assume that the objects that we're dealing with do not have any air drag acting on them, so that the only acceleration they have as they fall is negative 9.8 meters per second every second. If you drop it, you're dropping it from rest, so its initial velocity is 0. If you throw it up into the air, as it goes up, it slows down, it slows down, it slows down by 9.8 meters per second every second, but at the very top it has 0 velocity, and then it turns around and it starts to fall downward and pick up downward velocity until when it gets exactly where it started, it's traveling at the exact same speed. That means that when an object is just falling down through space towards the Earth's surface, that it picks up speed by the same amount every instant in time, but it goes further and further and further because it's going to have a parabolic position graph, right? It's going to go further and further because simply it's going faster and faster every instant in time. The kinematics equations are exactly the same as the other ones, except instead of an x, you're going to see a y, and instead of an a, you're going to see a g. The g is always going to be negative 9.8 meters per second squared. Later on, we'll talk about what if we throw it at a little bit further, throw it outward, not just straight up. What if we throw it at an angle? But right now, we're just talking about throwing it straight up. So if you think about throwing it up at 29.4 meters per second, after 1 second, it's going 19.6 meters per second. After 2 seconds, it's going 9.8 meters per second. At the top, it has 0 velocity, and then it picks up speed at the exact same rate that it had before. So, in the kinematics problems set, solutions, sample problems, I will go over a couple of example problems. Khan Academy videos are posted that also show you how to solve these problems, and the physics classroom does a really good job at it too.